let's create some static routes on a few Cisco routers. Come and join me. Let me show you what I have here in store for you. So we have three beautiful routers. Router 1, router 2, and router 3. Okay. We have here some networks. So this is the 10 network. This is a 10.11/24. This is the .1, this is the .2, this is the .1, this is the .2. Now I'm going to clear the clutter. Now that you know what type of scenario we are working with. So without further ado, let's jump right to it with this beautiful, big, beautiful bastard in the background, and let's check it out. So I am here. This is router 1, obviously. This is router 2, obviously. And this is router 3, obviously. So let's get some tests going. So since they are in different, so the remote routers are router 1 and router 3, being the router 2, the interconnecting router, all right? So being router 2, it's going to be the one who interconnects both. So let's try to ping from router 1 to router 3, and let's see what happens. So I'm going to ping from router 1. I'm going to ping 10.1.1.2, which is router 3, 10.1.1.2, and let's see what happens. As you can see here, pings are failing. It's not totally surprising because they are on remote networks. I will make a video more detailed about remote networks and how they work. But for now, let's resolve the issue and show you guys how can static routing fix this. I'm going to make another video about dynamic routing. Most likely, I will make a video using RIP and another video using OSPF for the exact same situation, so you guys can actually learn how can this get fixed. If you're watching this in the short term on the shorts or YouTube or TikTok, come to my YouTube channel, Ozzoy Beats on YouTube, and check the long form and see the solution. I'll see you there, guys. Here, for the people who are looking for the long haul, let's continue. So yeah, they don't ping. I could ping. Well, I will. I mean, I don't have nothing to lose here. Let me ping from 3 to 1. So ping 10.1.1, not 11.0.0.1, and there you go. So no pings are occurring. However, router 1 should be able to ping 10.0.0.1 and should ping the other guy, which is 10.1.1.2, 10.1.1.2. We should be safe in there. Bonus question: why does the first ping fail and all the rest of the pings work perfectly? Why is the first ping failing and the other one's pinging okay? 3, 2, 1. It's the ARP broadcast doing its thing correct. So it makes total sense to rely on router 2 to do the heavy lifting, okay? So it makes total sense to rely on router 2 to do our heavy lifting. So basically you're going to say router 1, when you want to reach router 3 or that network over there, so let's make it correct. So router 1, once you want to reach this network here, you should contact router 2. Okay, that's the first step. Let's do that. So as we know, let's go there now. So as you know, router 1 wants to reach the 10.1.1 network. So let's go here. So let's say on our global configuration mode, we will do IP route, which is the main command to do IP routing. I'm going to specify the destination network, which is 0.0.1, and the subnet mask 255.255.255.0. And I'm going to say, okay, router 1, when you want to reach that network, you will deliver your packets to router 2 and hope that router 2 will do its thing. Uh-oh, I did something that I didn't want to do. Now it's here, but everything is fine. Okay, so cool. So I'm going to say, okay, router 2, my side of router 2, it's 10.0.0.2, 10.0.0.2. Looking great. To confirm, we do show IP route, and there you have it. As for static routing, and it's telling me to reach the 10.1.1 network, you should contact 10.0.0.2, which is our router 2. Okay, so this is all the things you need to know. So this is our metric and our administrative distance, which is 1. If you were pointing to a local interface, it would be 0, but yeah, I could direct router 1 to speak to the interface, which is fine, since this is a theoretically point-to-point. but since it's Ethernet, you get a warning. It should work too. But in Ethernet, I do prefer to use the IP addresses. I use direct interfaces and I'm using point-to-point interfaces. But Ethernet, I like to tell them to use the IP address of the next hop router, which is router 2. Okay, cool. Now, in theory, I should be able to try and test ping 10.1.1.2. And let's see what happens. And we wait. And as you can see here, still does not work. So, bonus question, why is router 1 able, after installing the route, which is correct, router 1 knows that to reach this network, it goes through there. So why is router 1 still not being able to reach router 3? 5 seconds to think of the answer. 3, 2, 1. Because IP routing, it's not by default nor automatic bidirectional. So I need to configure a similar thing on router 3. So router 3 needs to learn that to reach that network, he will contact this side of router 2. Okay. So routing, it's not automatically bidirectional. So let's go in here and do that. So let's go to router 3, conf t. So router 2 here is kind of on the upper hand because he knows he's connected to both networks. He can deal with both. It's kind of the stepping stone for both networks, but not the edge routers. So let's go to the IP route. So 10.0.0.0, yeah, 255.255.255.0, and you should go through 10.1.1.1. This should be enough to fix. Let's confirm. Show IP route. Cool, and it's there. It means that we should be able now to ping one another. No problems at all. And we should be able to fix everything, and they should be able to ping one another. So let's try from here. 10.0.0.1. And now everybody can ping one another. And this is how you can make this network work with static IP addressing. There are not static IP addressing, static routing. There are other options. You can do a default route on the leaf routers, on the edge routers, or you can configure a dynamic routing protocol everywhere. I'm going to make a video about RIP, and I'm going to make a video about OSPF, and I'm going to make a video using default routes. So I'm going to make a default route video next. So can use default routes to fix this specific network situation, this specific network scenario. Like, subscribe and comment to get notified all about that. Like, subscribe and comment. It will help to get the channel growing, and get this information to most people that you can. One last time, like, subscribe and comment. It will help, and I'll see you in the next one. Cheers, guys.